40 light-years away, a tiny red dwarf star hosts a system of 7 Earth-sized planets. Among them, TRAPPIST-1e stands out. It sits squarely in the star's habitable zone, the sweet spot where liquid water could exist. But what is its atmosphere like? Does it even have one? These questions are exactly what NASA's James Webb Space Telescope, or JWST, is trying to answer. Today, we dive into the latest observations of this intriguing exoplanet and what they could tell us about the potential for life beyond Earth. The TRAPPIST-1 system is remarkable for its size and structure. All 7 planets are rocky, roughly the size of Earth, and orbit very close to their tiny, cool star. T1e is the 4th planet from the star and the most promising candidate for liquid water. Because red dwarf stars like TRAPPIST-1 are very different from our Sun, the planets here experience intense stellar flares. These flares can strip away a planet's atmosphere, making the question of T1e's habitability more complicated. JWST observes planets using infrared spectroscopy. As a planet transits or passes in front of its star, some starlight filters through the planet's atmosphere. Molecules in the atmosphere absorb specific wavelengths of light, leaving unique fingerprints in the spectrum. By studying these fingerprints, scientists can detect gases like water vapor, methane, carbon dioxide, and ammonia, key ingredients for understanding atmospheres and the potential for life. Recently, JWST observed T1e across 4 transits. This is just the beginning, but even these first observations are shedding light on the planet's atmospheric possibilities. The initial results are intriguing. The data suggests T1e has lost its primordial hydrogen-helium atmosphere, likely stripped away by stellar flares. But the story doesn't end there. The spectra hint at a secondary atmosphere, possibly composed of heavier, spectrally inactive gases like nitrogen, with small amounts of methane. Interestingly, T1e's atmosphere doesn't appear similar to Venus or Mars. There's little evidence for a thick carbon dioxide layer, meaning it might not have a strong greenhouse effect. Without it, maintaining surface water could be challenging, although even a modest greenhouse effect could help. Observing planets around a red dwarf like TRAPPIST-1 is not easy. Powerful stellar flares can distort the data, creating noise in the spectra. To address this, astronomers use a clever technique. They first observe T1b, the closest planet to the star. T1b is likely bare rock with no atmosphere, so any spectral artifacts seen there are purely stellar. These artifacts can then be removed from T1e's observations, giving a much clearer picture of its potential atmosphere. JWST has 15 more transits of T1e planned, each providing more detailed data. Scientists hope to confirm whether a secondary atmosphere exists and determine its composition. If T1e does have an atmosphere, it will be the first Earth-sized exoplanet in a habitable zone with detectable atmospheric features, a milestone in the search for habitable worlds. Why does this matter? Studying T1e's atmosphere moves us from simply discovering exoplanets to understanding them in detail. We can start to ask whether these worlds could support life, how atmospheres survive in harsh stellar environments, and what makes a planet truly habitable. Each observation brings us closer to answering one of humanity's oldest questions. Are we alone in the universe? The James Webb Space Telescope is revolutionizing our view of distant worlds. With TRAPPIST-1e, we are witnessing the dawn of detailed exoplanet atmosphere studies. The journey is just beginning, and every transit brings us closer to discovering the secrets of this distant Earth-like world.